everybody. Thanks for coming to Observe 2020. And yeah, thanks to everybody who organized this. It's an awesome day so far. My name is Lucy Monahan. I work for Toast. And this is a story of our observability. So Toast is a restaurant point of sale company. So we tend to talk about food a lot. We use a lot of food metaphors, and sometimes food ends up in our slides, just like this one. So this is our recipe for observability. First, a little bit about what Toast does. Yep, we're a restaurant point of sale company. If you go out to eat again, or even if you're getting takeout now, you might go to a Toast restaurant. We also do payroll and team management, online ordering and delivery, restaurant loyalty programs, and we also design and create our own hardware, which makes for interesting observability questions. There we go. Oh. So let's talk a little bit about the Toast ecosystem. The Toast point of sale is an Android app running on an Android device. It communicates a lot to a lot of cloud services, but this talk is about just the Android side and how we get our arms around what is a very large ecosystem of many Android devices out in production. So at the beginning of Toast, they started the point of sale, and they have a lot of Android tablets. They're stationary tablets, and they're in a restaurant, and they started monitoring those. And then as Toast grew, we had more stationary Android tablets doing the restaurant point of sale. And then the hardware team designed a new handheld device called the Toast Go. So the Toast Go presents different observability questions than a stationary device. For example, this handheld device is walking all around the restaurant, maybe into a walk-in freezer, or maybe out to a patio where the Wi-Fi connection is slightly different. So from an observability point of view, a Wi-Fi connection that is emitting different logging, maybe it depends on if that's a handheld device or a stationary one. Those are differences we need to see in observability. And then the other diversity factor out in our ecosystem is the Android operating system that's running on the devices. So these devices are expected to last, 5 years a restaurant might use them for. So they might not upgrade their Android operating system, which makes for maybe differences that we see in our observability. So a little bit about the topology. This is an example of 3 Toast point of sale systems. And the first one on the left has taken a restaurant order and sent it to the cloud. The thing I want you to see here is that the other 2 devices in the restaurant receive an instance of that order. So after the order completes a round trip, basically all 3 tablets are equal. Each tablet has a copy of each of the orders in memory. So as we progress, we have 3 tablets all taking orders and synchronizing orders. So traffic is starting to pick up. Then when you have a bigger place, yeah, you're adding more and more devices and more traffic. And for each of the devices, we need to monitor how much memory are they taking up? How fast are these requests going? How fast are the button pushes? How much processing power is being used? So we need to get our arms around all of this information on all these Android devices out in production. So how do you observe everything at once? I was listening to an earlier talk, and I think that you could say everything's important, but some things are really critical. So we have some operations that we define as business critical. And for those operations, we want to collect as much high cardinality data as possible. So at Toast, we call this the rule of 5. So as a company, we've coalesced around this notion that we have 5 high-level operations that are super important to us. And without them, we can't be successful. So let's talk about those. The first one is creating an order. I'm sure all of you are familiar with going to a restaurant and someone takes your order. The next one is sending an order to the kitchen. So that can be a device in the kitchen, or that could be a printer in the kitchen. And then the next one is delivering an order. Maybe that order is delivered to a table, or maybe it's delivered to an expediter, a person who works between the kitchen and the table and delivers the orders to the table, or can be takeout. Sorry. The next one is taking a payment. You can imagine taking a payment is very, very important to our customers. It must be reliable, especially. And then closing out the day. If you're working in a restaurant and you've been on your feet all day and it's 1 in the morning and you're ready to go home, you have to reconcile the day's receipts. You hope it's going to go fast. So we try and make that go really fast for our customers. And then one thing that's not in the rule of 5, but is behind all of these things is button presses, which are very important in the mobile world. So in the web world, if you have a request taking, say, 3 seconds or 4 seconds, you'll probably do okay. Your customers will still purchase whatever it is they're buying from you in e-commerce. But beyond 4 seconds, generally, you get threatened with abandonment of that customer. Well, the number is much, much smaller in the mobile world. The number is about 100 milliseconds or less for a button push. And between 100 milliseconds and 200 milliseconds, you'll still do okay. The user will not perceive a latency at this level. But if you go over 200 milliseconds, it's time to sound the alarm, because there will be a perceived latency from the user perspective. So for our customers, we have people working in restaurants. They're very familiar with their menu system, and they have a muscle memory that goes very fast. They take orders, they tap, tap, tap them in. Every time we deliver a new version of the app to them, those button pushes need to go as fast or faster to meet their expectations. So I'm going to use button tap as an example, because that's one probably we can all relate to on our phones. But when you imagine this example, we have many, many operations that we measure in this fashion off of the Android devices. So what we do is we measure each, using the button tap as an example, we measure each button tap, and then we say, we set a timer, how fast did it go, and then we measure it and store it locally. So the first button tap took, let's say, 10 milliseconds, and this is just an example for you. This isn't real data. And then the next button tap took 20 milliseconds. And then the next one took 30 milliseconds. So we're aggregating this data, and we're going to form a histogram of these metrics. And we're going to store the min, the max, the mean, P95, and then the size, which is the number of times this button was pushed. At some interval that is configurable, we're going to push this histogram up to Splunk, where we can track it and monitor and alert on it. After we push it up to Splunk, we clear that data on the device and we begin a new interval. So these metrics that we push up to Splunk are wide. We have a lot of data in each one of the histograms that get pushed up. We have a bunch of other data attached to it, such as device ID, device model, which version of the Android operating system, which version of our app was running on the device, the restaurant name, the restaurant group, device serial number, lots of information that we can track that has high cardinality, so that we can use that data to create dashboards and compare and contrast with other restaurants. So yeah, we chart, monitor, and alert on these metrics in Splunk. So let's talk about these metrics. These metrics are a vehicle for our developers to create their service level indicators. So what kind of metrics do we have available for all of our developers to wrap around operations in the Android app? Well, we have timers. That's the example we just saw. It's a button press. How long did it take from beginning to end? We have meters for faster growth, things that have counters, the number of times that something has happened. And we have gauges, which are generally used for slower growth, like memory. At some point in time, we'll take a snapshot and say, how much memory is being used right now? We'll stash it, push it up to Splunk with a timestamp. And then we have some other Android-related system level logging that we can scrape off the device, like app uptime, to help us complete the story of what's going on a device at any point in time. So this is our observability recipe for success. We want to collect lots and lots of high cardinality data about the important operations that are happening on these Android devices. Then we're going to use them to create trends and outliers. What is the expected behavior? What is the expected amount of time something should take? What if we start comparing restaurants that are the same? Maybe there's, using a lot of handhelds. This restaurant's using a lot of handhelds. Another one, should they perform the same? And if they're not, what is the difference? We can use that data to start understanding. So we have production observability is achieved. So you could say we're all done, but you really need to know news earlier in the cycle. So what we did was we used the Espresso Framework, which is the UI test framework for Android. And using that test framework, we wrote scripts that drive user actions that will generate metrics that we can push up to Splunk. And we can run this test against a restaurant that is a good approximation of a lot of our restaurants. So we can get a really good idea of how these metrics are performing on a new app version before we push it out. And then the next step was to wrap a Jenkins pipeline around it so we can kick it off anytime we want. We can kick it off in pre-production, which is an environment that is like production. And we can use preview versions of our app to make sure that our performance is still measuring up to what we expect. So at our pre-production stage and our preview of our app, observability is now achieved. But what about our developers? They want to know what's going on when they're making changes too. So we took that test environment of an Espresso test driving the user actions in a test, and we converted that pipeline so that you could hand in any branch from Git that you want. So previously, it just took whatever was the version of our preview app. Now developers can add a button push with one parameter, enter the name of their Git branch, we'll pull it down, build it, and run this test in pre-production so that they can get an idea of a before and after of performance before they make a PR. They will know exactly where they stand and whether or not their changes affected performance. So that brings us to our slows. We have service level indicators. We gave our developers a way to measure them. And now we want to give them a way to build out their service level objectives. So what we did in our performance group is we built out a whole bunch of templated dashboards that teams can use to plug and play their slows. So remember I told you we have events that are wide. They have different pieces of data on them. Well, teams can come to these templated dashboards and they can plug in the metric that they're interested in, say for their group, the version of our app, the type of device it's running on, and they can measure what's going on in production and make sure that everything is expected. They can also plug in different restaurants because we have different restaurants with different performance profiles depending on how big is the restaurant, how big is the menu, and things like this. So teams can keep an eye on certain restaurants and get an idea how they're doing. And they didn't have to build out the dashboard, it's plug and play. So this is our recipe for observability culture. As a company, we coalesced around specific business critical operations. We all agree these things are very important. Then we instrumented our code so we can capture key metrics used for defining our service level indicators. Then as a team, the performance team, we provide tools and automated test frameworks for our teams to constantly measure all their operations before shipping and before creating a PR. They can do a before and after of their branch compared to the branch before their changes were in it. We use Splunk to monitor and alert on all of these metrics. And we provided plug and play templated dashboards so that teams can monitor their slows. If we make it easy for them to do it, they will be happy to do it. So we try and smooth all of that and everybody's happy. It's blocked a little bit down there, but we also have a type of office hours so teams can come and see us. We can share ideas, they can get assistance from us and come up with new ideas for how we can test and how we can help those teams. So you heard my colleague Chris earlier in the day tell you about Rally for Restaurants. This is an initiative that has been launched in light of COVID-19 to help the restaurant industry to survive this time period that we're going through. So I wanted to add this slide at the end of my presentation to remind you to please visit Rally for Restaurants. Maybe find a restaurant in your area that you like, get a gift card from them, maybe order from them, and help them get through this time. And thank you for listening to my talk.